In this video, I'm gonna talk about one of the BGP attributes, the next hop attribute. So in the last video, I talked about how BGP, builds, its sessions, or builds its peerings with the other BGP or with the other BGP speaking routers. Today I'm gonna talk about, or in this video I'm gonna talk about the next hop attribute. So I've got a new topology here. So let me just show you the topology, or explain the topology here. So we've got 9 routers, and these routers are all configured with BGP, and also I used OSPF as the IDP so that the BGP speaking routers can establish peerings between each other. So let's take a look at ITC configuration, BGP configuration. So I'm gonna do, of course, I have already configured all the routers, the interfaces, and the BGP configuration, and the OSPF configuration. I have completed all that, so I'm just gonna show you the just for the sake of reviewing the configuration, let me just show you the configuration of BGP on each router. So show run, this is ITC, yeah, that's the BGP configuration on ITC router. Let me do a show IP BGP neighbors, or actually that's a lot of information, so I'm just gonna do a show IP BGP summary. So as you can see, it's got a BGP peering with ITA, that's the IP here, and it's got a BGP peering also with ITD, that's the IP address. So let's go to ITD. Let me show you the BGP configuration again. So that's the BGP configuration. And let me show you BGP summary. So ITD has a BGP peering, or has a BGP peering with ITF, that's the IP address, 192.68.5.1, and it's got another BGP peering with ITC here, that's the IP address, 192.68.6.2. Let's go to RTA. Did I say RTA? I said it should be RTC. So let's go to RTA. Actually, I'm using a solar putty. So this is much better than just regular putty. So you can just change your tab to get to the correct router. So this is RTA. So let me do show run pipe section BGP. So that's the BGP configuration on ITA. Let me do a show IP BGP summary. So as expected, it's got two BGP peerings. It has a peering with ITF and ITC. You just have to review the IP addresses here. These are the neighbors. Let's go to ITF. Oops. Actually, like I said, I just have to change your tab. So show run pipe section BGP. So this is the BGP configuration on ITF. So show IP BGP summary. So as expected, it has two BGP peerings with the other routers. So this video is we are focusing on the next hop attribute. So I've got some notes here, important notes. There are a couple of ways to make sure that you don't have problems reaching the EBGP next hop. So number one, the first way is to include the network that the next hop belongs to let me read that again. The first way is to include the network that the next hop belongs to in the IDP. So let me give you an example of that, or let me show you an example of that. So let's look at RTA. Like I said, the IDP that we are using on these routers is ITF. So meaning that, close that, ITF or RTA, there's RTA. Let me read it again. The first way is to include the network that the next hop belongs to in the IDP. So actually I'm gonna go to RTF, show IP BGP. So in this output, 192.68.11.0 is being learned via this IP address here. This is not the next hop IP address. The next hop IP address is 172.16.1.1. So the reason why this next hop is actually this IP address here is the next hop is because the network that this next hop belongs to is actually configured the next hop, the network that next hop belongs to is actually configured in the IDP. In our example, or in our case, OSPF. So let me show you the configuration of. Let me show you the OSPF configuration. OSPF configuration. Oops, not included. So here, this next hop or this IP address belongs to that network, and that network is configured on both ITA and ITF. So ITA is the, let me show you the, also show you the configuration, BGP config, the OSPF configuration on ITA, OSPF. So here it's got, you know, the same network configuration as ITF. They both belong to area 0 also. Passive, the reason why I configured passive interface here is because ITC it doesn't have, ITC doesn't have an IDP configuration, well, in this case ITF, I mean OSPF configuration. So this router ITF, it's not gonna send OSPF updates to that ITC router. So the next one is to use the next hop self neighbor command to force the router to advertise itself rather than the external peer as the next hop. So an example of that is ITF router. Let's look at ITF. So I configured next hop self command again. Next hop self on ITF on the neighbor. Let me show you what I mean. So let's go to show run section BGP. So here, so this is the configuration of neighbor 172.16.2.5254. So this is what I mean. I configured next hop on this particular neighbor, because I want to send updates to that neighbor, and I want that neighbor to use my next hop or my IP address, not the IP address of ITD, which is 192.68.5.2. So if we go to ITA, we're gonna see, and we do a show IP BGP, we're actually gonna see that let's say the network 192.8.10.0/24, it's the next hop IP is the IP address of ITF, not that IP address, not RTD's IP address. So, but if I remove the next hop command here, ITA, oops, ITA is not gonna ping this IP address, so it's not gonna be in the IP routing table, because that IP address is not reachable on ITA. So yeah, those are the two ways that you can that you can perform for you to make sure that you're not gonna have problems switching the EBGP next hop IP addresses, or just the EBGP next hops. So yeah, that's it in this video. Thanks for watching.